High temperature is not one universal fan class. Start with the declared duty, continuous hot gas, repeated thermal cycling, a transient upset, or an emergency smoke time temperature profile. State temperature, duration, ramp rate, gas chemistry, speed and cooling conditions. A standard fan and a high temperature design can be compared only against that same duty. Separate the thermal zones. Gas stream temperature differs from wheel, shaft, and housing metal temperature, bearing and lubricant temperature, motor or drive ambient, and an accessible surface temperature. Radiation, conduction, convection, insulation, and purge or cooling flow create different local conditions. One thermocouple cannot approve the complete assembly. Melting point is the wrong shortcut. Long before metal melts, elevated temperature strength and stiffness can fall, fatigue margin can change, and time-dependent creep can accumulate. A torch, glow color, or heated coupon does not qualify wheel speed, weld life, or a complete fan. Engineering needs temperature-dependent properties, stress, time, geometry, and fabrication details. Material selection is a chemistry and life decision, not a stainless versus carbon steel slogan. Specify exact grade, product form, heat treatment, and weld condition. Check elevated strength, creep, oxidation, carburization or sulfidation, chloride or acid corrosion, abrasion, deposits, and thermal cycling. A higher alloy can solve one mechanism while changing cost, weldability, and thermal growth. The rotating assembly sets hard limits. Hub, blades, shrouds, welds and fasteners experience centrifugal and aerodynamic stress while corrosion, erosion or deposits alter section thickness and balance. Allowable speed can require temperature derating. Similar-looking housings do not make two wheels thermally equivalent, use the exact manufacturer speed temperature envelope. Thermal expansion changes clearances and alignment. Wheel diameter, shaft length, inlet cone, housing and supports grow by different amounts and at different rates. Preserve radial and axial clearance from cold start through heat up, steady operation, upset and cool down. Duct expansion joints and supports must keep thermal loads away from the fan instead of locking everything rigidly. Shaft, bearings, lubricant and cooling form one thermal system. Bearings in motors are often positioned outside the hot gas path, with engineered heat slingers, insulation, purge air, liquid or oil cooling where required. Bearing clearance, load, speed, lubricant viscosity, seals and service interval depend on actual bearing temperature. High-temperature grease alone is not a design. Check the entire drive arrangement. A motor insulation class does not authorize arbitrary furnace ambient or placement inside the hot stream. Direct drive can conduct more heat into motor bearings. An indirect drive can move the motor away but adds shaft, coupling, or belt, alignment and guarding issues. Cooling loss, blocked purge and remote restart need defined alarm and trip responses. Cold start may be the highest power state. Colder gas is denser than the rated hot gas, so the same volumetric flow can demand more aerodynamic power. Verify cold start, heat up, normal and maximum temperature, upset and cool down for airflow, pressure, speed, current, power and stable operation. Use one declared actual or normalized gas basis for every curve. High temperature process duty is not smoke control or explosion certification. A continuous kiln or dryer fan and a powered smoke and heat ventilator have different objectives in verification. Hot gas capability also does not prove spark resistance, corrosion resistance, or hazardous area suitability. Solvent vapor, fuel, dust or oxygen-deficient gas require complete furnace process hazard review. Design for people, deposits, and shutdown. Insulate or guard hot surfaces, contain leakage, provide cleaning and inspection access, monitor hot state vibration, and account for erosion, corrosion, and condensate during cooldown. Before service, isolate the process, lock out electrical and auxiliary energy, verify isolation, purge or depressurize as required, and wait for adequate cooldown. Release a whole fan thermal passport. Record duty type, temperature time profile, gas chemistry, exact materials and welds, speed derating, cold and hot clearances, bearing and drive limits, cooling and failure response, aerodynamic conversion basis, vibration limits, protection, access and approved start-stop sequence. Missing evidence means the high temperature claim remains open.